data, reshaping data. So we're going to look now at, we've just looked at this data rectangles example in the previous video. Now we're going to have a little look at structuring the data and reshaping it. And again, we're going to continue using the same case study as we were before, of this change in Omani livelihoods over time. Just to recap, in the last video, we had a, I'll talk about what we did in the last video in a second, but I mean, just to recap, the Omani data set, it's given in more detail in topic 1, but this case study examines survey data taken at 2 time points and illustrates a changing nature of farming ecosystems. The aim of the case study is to both document what happened in the past and consider perspectives for the future. So our aim here is, let's say we want to investigate whether certain livestock cause certain diseases. To do this, we need to merge 2 sheets together: animal numbers by decades and views about farming and tourism. There's 3 steps to do this. Number 1, we need to ensure that the data sheets, because there's 2 sheets, there's 2 data sets, we need to ensure that those sheets are in a rectangular format. And I will just say at this point, when I say sheets, I still mean data. I mean that data set. We then need to rearrange the data to be in the correct format for merging, and then we can merge them together. So we're going to focus on step 1 now, ensuring that the sheets are in a rectangular format. In the previous video, we looked at data rectangles, and I really advise that you have a little look at that video if you haven't yet. In here, we said that there's these 7 sheets in the Omani data, 6 of which contain a set of variables for the individuals by year, or for the different households by year. 6 of them are therefore data rectangles because the columns are all the same length and the rows are all the same width within a single sheet. In a spreadsheet file, there can also be sheets with results or kind of summaries. In the Omani data, the 7th sheet is not in a rectangular format, but more in a pivot table format. Have a look at the sheet, animal numbers by decade. Here we have these 2 column names where we have row 1 and row 2 give us our column names, and we have a duplication of column names as well. So what happens if we put a data set like this into a statistical software like our Instat? Well, it gets very confused. It assumes that that first row are your column names. So now it's renamed some of the data. We've got these rows here which are not very usefully named, such as ... 1, which should be named village. And we've also, our Instat has very helpfully for us sorted out that duplication of names, where it's gone, okay, X. So what was 1988, it's given it a 3 after it to distinguish it from the other 1988, because we have to have unique names. Similarly, with 1998 has been given a number after it just to help distinguish them. Another thing that we want to look at as well here is this little c. It's saying that it's a character column. Well, actually, these aren't meant to be character columns. Our column 3 onwards are meant to be numerical columns, because these columns give a number, but it's giving it as a character column. So what we can do is we can rename that first row, and we can delete that second row and change our character columns to be numerical columns so that everything's a lot more meaningful and so that we can achieve our aims. Now, there are guides on how to do this. If you look in the how-to guides at the end of this topic, there are some guides on how you can achieve this in our Instat. In any software of your choice, you will be able to achieve this. And there'll be plenty of resources online if you're not sure how to. By doing this, our column names are now a lot more meaningful. They're a lot easier to read as well. Go to 1988 is a lot easier to read than X 1988 ... 3, just my own personal preference. And it's in a much more understandable format because we can remove that first row of data, which isn't actually data showing results. So let's go back to our aim. We want to investigate whether certain livestock cause certain issues. To do this, we need to merge our animal numbers by decade sheet with our views about farming and tourism sheet. We firstly wanted to ensure that the sheets are in a rectangular format, and we've now achieved this. What we next need to do is rearrange the data to be in the correct format for merging. What do I mean by this? So we need the data sheet to be in a consistent format to our other sheets from the Omani survey. This means that here we want to have a year column, since it's important to merge by year, and we want to have a livestock column for the type of livestock. So as we can see, we have taken our data, which was back here, and had our lots of different columns, and we've separated it such that we now have our name, which gives us what was our previous column names for a lot of them. So goats 1988, goats 1998, etc. And our value for them. This is called stacking or putting them into a longer format. And there's guides as well in the resources section on how to do this in R and R in Stat. We now have a much longer table. And as you can see, we have things repeated a lot. So we have 12 versions of our first village with SH1. But it's unique by the animal type and the name. So what we're going to do is we can split that name column into two, and we can have then goats and we can have year. Now we can treat them as separate variables. So now we've got village, household, animal, year, and then value, which is the number of livestock. We need to have it this way so that we can merge it with other data sheets in the Omani survey. This is because in the other data sheets in the Omani survey, they also have their data laid out that they have village, household, year, and so forth. So we want to have it that way. We have a data frame in a longer format now with 5 variables. Each variable is meaningful, and each row is at the household, animal, and year level. What I mean by this is that each row is unique for each household, animal, and year. We do not have SH1 goats in 1988 again in this data. So now that we've rearranged the data, we can actually we can view it in a graph and get a lot more meaningful information, such as a plot. So here we've got a plot where, well, actually we have many plots where we have the household and we have the animal name or the animal type, and we have the number of livestock. And so our first row of that data is giving for one of the villages, the second is given for another village, and the third is given for a third village. And each of our columns are giving us different animals, and it's colored by each individual household. So we can kind of just see overall on how different people's livestock ownership have changed over the years. So for example, for goats, we see, well, in our first village, most people actually have decreased in their goat ownership between 1990 and I think, is that one 2008? Or it might be 2007, but between 1990 and our third time point, most people have decreased in ownership of goats in this region. However, in our third village, it's actually been quite steady, and there's a bit more of an increase between our third and fourth time point. Anyway, we'll go back to our aim. We wanted to investigate whether certain livestock cause certain issues. And we're merging these two sheets together. We've now done our data rectangle format, we've rearranged them, and now we can finally merge them together. So we merge them together. We can merge our new longer data set with the other data set, the views about farming and tourism. And we can then look at the frequency of animal and the most important task concerning livestock. So now that we've merged them, and again in the guides at the bottom is an explanation on how you can merge. But now that we've merged them, we can analyze our data. Analyzing the data. So if we look just at goats, in 2007, we see that 60% of farmers with goats had no issues with livestock. That's here, 15 of our farmers who owned goats said that they do not have any issues with livestock. However, in 2018, this had decreased to only 4 farmers had said that they have no issues with livestock. And actually, most farmers said that they had issues with diseases. 63.6% of farmers found that they had an issue in their goat population with disease. Similarly, for other livestock, we can see an increase in the disease as well. Here we are with cattle, where back in 2007, only 2, and that was as much as 25% because we don't have much data here, but 2 farmers said that they had issues with diseases. Now we have 10 farmers in 2018 saying that they've got an issue with diseases in their cattle. And finally with sheep, where it's gone up from none in 2007 to 7, or 58.3% of farmers finding an issue in disease with their sheep. Now, as I said, it's a very small set of data, so there's not enough livestock to definitively say anything or to draw anything, but it does look like that disease is a problem for farmers in 2018, regardless of their livestock type. And this is a finding that we could find by merging those 2 data sets together. So overall, a data rectangle refers to the way to format the data in a clear manner. Other statistical software use a data rectangle for the data. Therefore, a rectangular format is a lot more consistent with other statistical software. Rearranging data is straightforward in a statistics package, but it can be messier in a spreadsheet software. A spreadsheet software may need copy and paste to achieve this, and this can create huge problems. Any copy and paste opens the doors for errors, and so it should be avoided. By rearranging and merging data in a statistics software, we can safely and easily make more inferences about the data. Thank you very much.